This is the third exercise on PySpark. In this exercise, we are going to be dealing with Instacart Online Grocery Dataset, which can be found on Kaggle. The files I the files were downloaded manually and they can be found in this folder. You can go to this link and download it for yourself or do automatic download as instructed. Here we're opening Spark sessions and going through the files. I'm not going through the details of loading process. Some types were casted. So we have these files: aisles, departments, orders, order products prior, order products train, and products. This was used for some data science model training, but we are going to do simple querying on this data set. Okay, this is the schema who likes it. Aisles with two fields, departments, order products prior, order products train. So basically had to predict these values in data science. And products, and here these all these tables or data sets are short referenced. These are possible joins between them, just done for inspection. Uh, Here are some results, and so we are finally going to the exercises themselves. Okay, the first exercise is to do filtering by comparison. So product name should be all seasons sold. We can do this using cos equals constant, or we can take these products like in data frame, or we can use expression syntax product name. All three give the same result. Okay, filter products where product name starts with G. This can be done in numerous ways. Starts with function, like function, like function. This is beginning of the word. Uh, this is these three are doing the same with expression syntax. Like starts with. All six methods give the same result. Okay, now ends with the same thing. Um, ends ends with column, like column, and like column. All produce the same results. I used select with substring from the end to show the end of the string, so we see S at all cases. All three results are the same. Okay, filter products where product name contains chocolate. Again, can be done by like, can be done by like, by call contains, and by insert functions. There are probably some more methods. All results are the same. Okay, filter products where product name contains either salt or paper. I did it via like product name two words. Okay, and we can see salt, salt. Here it contains paper. Okay, filter products where product name matches a regex starting with A. Basically, this is what we done, but this exercise requires to use like, so we can tell call like, or we can do expression expression, product name are like a two results are the same. Okay, filter aisles where aisle name contains the word cheese. Um, I didn't do here the simple substring. I made sure we deal with the whole word. So slash b is the whole word syntax in the regular expression. So you can see the use of R. This R means that slash is a symbol. If we don't use R, it would transform it into slash B and we won't achieve the result. This is without R, we have to double slash. So the string will contain single slash. Uh, slash slash would convert to one symbol of slash. Okay. Uh, the result provides only those aisles which contain the word cheese. There are two more which contain the word cheeses. Okay, filter aisles where aisle name starts with S, case insensitive. This is case insensitive hint. Basically, also we can do this, but these two expressions are equivalent. So we placed small s and we achieved the same result as this. There are only lowercase aisles, so we continue. Filter departments where department name ends with E. We have already done this. Uh, Here is the trick of doing it with uppercase and endsWith. EndsWith is case sensitive. Okay, all three results are the same. Filter departments where department name contains O and it's at least 5 characters long. Okay, contains own and is at least 5 symbols long. These are the names. Exercise 4. Filter products where product name doesn't contain chocolate. So not column name are like chocolate. So we don't see chocolate in any of these names. So let's continue. Filter products where product name length is greater than 15. Okay, length call product name greater than 16, or we can use expression to achieve the same result. Okay, filter products where product name contains a digit. So digit is either slash D or it can be written as 0-9 in brackets. The results are the same. Filter products where product name contains lowercase a but not e. Okay, so this is contains a and this is not contains e. Not sure if lowercase applies to both. I believe by English grammar it means that A is lowercase and E is lowercase, not lowercase e. Okay. Next thing, filter products where product name contains exactly one word. So this is this can be done by start of string, word symbol, and end of string. Actually, I believe we need to place plus because otherwise it can match empty string, but we don't have empty string here. Okay, filter products where product name contains organic or natural, case insensitive. Uh, so we can do this, and I specifically placed organic in a lower case because the original constants are, capitalized. So we have organic, 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 and here we have natural, natural, it's natural, natural, natural. Okay, you see, I will filtered results of this DF16. Okay, filter products where product name starts with R and ends with S. Okay, this is case insensitive, and here we have it. Starts with R and ends with S, all three. Okay, filter IOs that contain a space in their name. So it can be done using like, or it can be done using r-like, or it can be done using contains. All three contain all results contain space names. Filter products where product name contains cheese but ignore a case. So okay, r-like cheese, and cheese can be in any case. Here lowercase, here is capitalized. Filter products where product name contains either chocolate or vanilla using regex. Okay, case insensitive chocolate or vanilla. These are chocolates, these are vanilla. Okay, convert product name to a lowercase. Add a new column called product name lower. Okay, with column lower product name. This is capitalized, this is lowercase. Convert product name to uppercase. Add a new column product name upper. Okay, this is new column with uppercase. The previous was lowercase. Apply initcap to all names. Capitalize first letter of each word. Okay, this is done by initcap function, and as you can see, the first words are capitalized. Specialty cheese, specialty cheeses, lowercase, specialty cheeses, capitalized. Okay, trim leading trailing spaces from department names using trim. Okay, trim column, not sure if names to be trimmed existed. Okay, remove only leading spaces. Okay, this is ltrim, the same. And remove only trailing spaces. This is done by rtrim. Okay, part product names on the left to a length of 25 characters using asterisk. Okay, I did the wrong thing. Okay, this is the right thing. Lpart 25 symbols asterisk. So the short name was lpadded. Other names were not changed. Okay, part product name on the right to a length of 30 characters using dash. This was right. Uh, the long names were padded with dashes at the right. And actually, this was not truncated. Other strings were actually cut to 30 symbols, though I didn't do substring. Okay, clean all names by trimming and converting to initcap in a single step. So we did trim and initcap in a single step. Specialty cheers. Create a new column showing the length difference before versus after trim. So these are two lengths before, length after trim, but they're the same. I checked if there are any rows which have different lengths. There are no such rows. Okay, new set of exercises. Exercise: compute the character length for product name using length. Okay, length of column name. Compute the character length of product name using char length. Basically, this is the same. Char length and length are the same things. Compute the octet by length of the department names. This is octet names. This is compared to length name, and I don't see the difference either, though it might actually be. Okay, compute bit lengths of alt names. So these are the bit lengths. What? No, I believe this is not what expected. Okay, this is the bit length of the string. Basically, number of bytes multiplied by 8, or maybe more. Who knows if special characters exist. Okay, compare length and octet length for product name in one data frame. So length, octet length, difference. So there are some, I filter it where it is different. No, I filter it where it is 0. So yes, I filter it the difference to be not 0, meaning please find those which are different. Okay, let's actually maybe add the product name itself to see what we've got. Yes, it has some special symbols. Yes, those which have special symbols have different lengths between octet and normal length. Okay, concatenate product name and ID using concat. This is done by using concat. Okay, concatenate department ID and department name using concat vs concat with separator. Okay, here is concatenation. Create a formatted string, product ID, product name using format string. So we have product D means digit, S means string, call product ID, call product name, alias formatted string. So this is the result. Okay, create a formatted IL label using print IL %D %S. Call IL ID, call IL. This is string. Again, the same thing. These are substituted as format. Oh no, this required to use print. Okay, I have fixed it. So print cannot be used as a function in PySpark. It cannot be used inside SQL. So we have two options. We either can use expression or we can write the SQL completely. So both produce the same results in two different ways: formatted string and print string. But you can do format string as PySpark inside Python, and you can do only prints inside expression or SQL. Okay, build a full descriptive label using concat vs product done. So I have concated this whole thing, backsplashed quotes, and here is what was expected. Okay, next set of exercises. Using the product data frame, it can extract the first 10 characters. Okay, this is substring, the first 10 characters. Using products, extract the text before the first space into a new column, first word. use substring index. So basically we have taken substring index of space and extracted the first word. I'm not sure how is this going to work on single word. It will produce -1. Okay. Uh, it actually works fine. What it does, it actually splits the string into words by this separator and takes the first word. So it doesn't matter if it contains the single word. It will take this single word. Okay, extract the last word of product name into a column last word. Here is the same, but we are taking the last word by -1. So it creates a list of one or more words and we take -1. Okay, we might need to check for empty string, but I'm not going to do this. Or string containing no no words, only white space. Split product name into array of words, name tokens. Okay, so we have split product name by space, and here we have the list. Basically substring index uh, takes one single word after splitting, and this provides the collection. Exercise 5. Split product name into words, then explode each word into its own row. So we should use explode. So it's 3 words, and each word is placed in a separate row. 2 words, 2 rows. 5 words, 5 rows. So this is basically something like outer applying a method query. I tried to play and use explode 2 times, so basically we have cross join 3 words, 9 rows, 2 words, eight, 4 rows, 5 words. We should have 25 of them, and here we have a lot more of them. Okay. Replace spaces in product name with underscores using translate. So translate replaces certain symbols. It translates space into underscore. As far as I understand, you can use more than one letter here and more than one letter here. To translate multiple things. What if we also translate dash to asterisk? Yes, it did translate a dash into asterisk as well. So we can do more than one character. Replace characters 1 to 5 in product name with the string xxx. Use overlay. So overlays the product name. I'm not sure what would happen if there are not enough symbols. Let's check it. Okay, nothing non-optimum has happened where less than 50 symbols exist. It simply overlaid or replaced the whole string with this substring. Where the symbol did exist, it replaced only first 50 symbols and left some characters after it. So the first 50 were replaced by these 5. Okay, next. Reverse the product name string under reverse. Okay, we simply reverse the column and we have the gobbledygook reversed columns. And else data frame left path else ID with zeros to length form. Okay. L path LID to 0, 001, 0011. So the number of four characters. In department data frame right path department to the length of 20 using dots. Okay, here we are padded it to 20 using dots. Okay, another exercise. Um, from products, create a column has chocolate. That is true if product name contains the substring chocolate. So I have done it in a multiple ways. When contains chocolate, true, false. This is not nice. Where contains are like are like case. This is case sensitive. This is case insensitive by default. Insert above zero or it's like percent. Okay, the results are the same. Okay, create a column is sold product. That is true if product name matches SQL like pattern sold use call product name like sold. Okay, called is sold products. Okay, false true, false false false. Create capital start or not true if product name start with a capital letter. Regex. Okay, no, I simply compared product name start of string and characters, capital characters. So uh, here we have uh, numbers. Okay, create T pose showing the first base position of T in a product name. So T should be in the first place. Uh, the first base position of T in the product name. So I checked if it contains, if it simply contains T. So it's either instar case then instant above zero, then product name contains T. I think this means first base position means that searching from the first character. It doesn't mean that the T should be in the first word. Okay, so uh, this is by default T. Here here it returns zero, and here it returns null if not found. So here I checked if it has t-pos, if t-pos is above zero, this cases, and this is where t-pos is not above zero. Okay, this is zero and this is null. Okay, create a column sold pos showing locate sold product name. So it it finds sold in the product using locate. Okay, locate works the same way as instar. It finds the position of the word, but it has the third parameter which can specify the start position for searching. Otherwise, they work the same. Okay, instar and locate, yes, these are producing different results if you specify start position. Okay, extract the first word to product name into a new column first word. So uh, the first idea is to use not space a regular expression. The second idea is to use a word symbol, a regular expression, and this is test if this is going to work, and it didn't. And the difference is, I tested what would happen if I pass an empty string. Okay, it has no problem of parsing empty string and the first word of empty string is empty string. Okay, extract trailing digits from product name into column digits. So trailing the last digits. End of word. Regex extract from the first position. So if no digits exist, uh, here are no digits. Oh no, this is the case where digits were found. We call this is checked, uh, and here I check if digits are really digits. Okay, any case, those places where digits exist in the end they were found. Create new column, no digits containing product name with all digits removed. So we have to remove digits. Regex, replace 09 in brackets. We can actually use slash d to do this as well. Okay, create multi-space true product name has two or more consecutive spaces. Okay, I used like to detect double spaces, so regex could be used. Uh, Create normalized name by converting multiple spaces into one. Here is multiple spaces much, and here is single space. So the product name was stripped of double spaces, and here are some examples where the reduction has occurred, like product name minus length of product name 2 stripped of spaces. Here are some above zero values. Okay, here we have some 5 spaces, and they were removed. Six spaces were replaced with 1 space. Okay, data frames already loaded. Exercise use ASCII to extract the ASCII value of the first character. We simply should use ASCII on the column, and it will give ASCII of the first character. Convert product name to base 64. Okay, base 64 on column. Here is how it looks like. And this is the length difference. Base 64 is longer, but not much. 1.5 longer. And because the base 64 using unbased, so we uh, to base 64 we unbase it, and then we decode it as UTF-8, and it's the same string. I checked if it's actually the same string everywhere and no rows. Format numbers using format number. Okay, format number to up for 2 digits after the comma. After okay, and use format string to create a formatted label in this format. Okay, format string. We have seen it above already. Compute soundx. Soundx pretty old function showing similarity of uh, a pronunciation for the string. Create cryptographic hashes. Okay, MD5 SHA2. Here how they look like. SH2 is longer. Okay, I just for fun calculated all possible hashes that are available in Spark. So MD5, these are six of, six of them. Some of them simple. CRC32. Uh, this is 64. Hash int is can be negative. Okay. Extract value from JSON using getJSON object. Build a fake JSON column. Okay, we use struct and we use two JSON around it, and we have JSON. Okay, convert product name into array using split exploded. So we split and we exploded. We have done it already. Split by space and okay, checklet sandwich cookies we have already seen it. Uh, posexplode. Yes, uh, this is the same as explode, but it's word index. It's like enumerate in for loop row number over words. 013 chocolate sandwich cookies. 01 all season salt. Join order strings using array join. Okay, here we join several columns into array and then using array join. So it concatenates values by adding separator. It can be done inside expression or SQL as well. Array join of array and so on. Okay, exercise 1B. These are the exercises about JSON, the last part. Build a JSON string for each order with the order ID. So we have JSON and we need to extract order. First we create JSON. Uh, yes, here we have to create JSON in this exercise. So to JSON over struct, and here is JSON. Say to extract user value from JSON using getJSON object. So we take the outputs xadin and we use getJSON. This is the JSON path for user ID, and we got user ID which is 1. Okay, a build nested JSON with order ID on an array of product IDs from prior orders. Okay, we do grouping, a group by order ID, and we collect list of product IDs. The end result is we have lists against order. And now we can convert it into JSON. And here is how it looks like. It has order ID and it has product IDs as a collection or list or array, how do you want it. Okay, extract array from nested JSON. So we have to extract this array. We do it by simple JSON path, and we have array back to where it was. Create JSON string with multiple fields using JSON tuple. So basically JSON. So we first create this multiple fields JSON. Simple JSON containing 3 fields. Here it is. And here we do JSON tuple. So basically it takes JSON column containing JSON, and it extracts three fields at the same time and aliases them. So they are being extracted back. Nested array JSON product plus IL. JSON products with ILs to and create JSON. Okay, so to JSON struct we have product name and we have IL, and we have printed it. Okay, extract product from nested JSON. Okay, this was product name and JSON, and we have extracted product name. Okay, uh, JSON array inside JSON multiple product names. Okay, this requires to collect JSON with collection inside it. So we do join, we do group by, we do aggregation using collect list, which is aggregate function, by the way. And here we have order ID and a list of products as strings. And here we convert them into JSON, and we have a JSON products and nested list of names of products. Okay, extract first products from product array. Basically, we need to use different JSON paths. It's products and first element, which is zero indexed. Okay, and we have French vanilla creamer here, and we have light here, the first product. The site combine JSON tuple and array inside JSON. Okay, we have JSON struct and create order user and arrays of products. Okay, and we have what here is what we've got. We got order ID, user ID, and product IDs. And here we do not have product IDs, it's null. It only contains order ID and user ID and no product IDs. Okay, and now we combine them. We uh, have order ID, user ID, and a list of product IDs. And this is some more. No, this is the same result for extend, but order ID is filtered by a modular 10,000. Okay, this was the last exercise on various PySpark functions. Then we will proceed to aggregations and window functions. This one was long, but it encompasses the vast list. It encompasses the vast range of Spark functions.